So what do you want to be like after your 12th standard? Have you thought about?
That all depends. I have no idea.
Okay, what you don't want to be?
That too, I have no idea.
That was you don't have any. Like, I mean, you're open to everything. That means you can, if you want, then you can, like give NEET, and if you get results, then you can also pursue MBBS. Or
Yeah.
yeah, okay, you're fine with that also.
Mm.
Are you interested in psychology, Shaheen?
Yeah, somewhat I am.
Some.
Even for
Which is
psychology, it requires
Mhm.
4 years of MBBS.
4 years of?
5 years, sorry. It requires MBBS for being a
Isn't
psychiatrist.
that for
So
psychiatrists? Yeah.
Yeah, that's for psychiatrist. But for psychologist, you need a degree in psychology.
Yeah, and masters.
BSc, no,
Yeah.
not BSc, bachelor's in psychology.
Sorry,
Bachelor's in psychology.
bachelor's in
You
Something
can
like
get a
that.
science, and
BSc
then
as
you
well.
have. Yeah, Matthew, tell me what you're saying.
Yeah, you could get a BSc, BA, or B Psych. You can go
Yeah,
either
yeah,
way.
yeah, yeah. That's true. That's true. I mean, you can. I mean, different universities offer different type of degrees, but again, all of this will be bachelor's only. Like bachelor's in science with psychology honors, or bachelor in arts with psychology honors. And I think I have not heard about this, but it may be also somewhere like bachelor's in psychology. That's so. What is going to be the difference between psychologist and psychiatrist?
A psychiatrist can prescribe medicines, but
Yeah.
psychologists can only do the therapy.
Psychologists can like they are more for therapy, and also like there are psychologists who are also used in big industries. Okay, and in HR department, you will always have someone with a psychology degree in the human resource department, and yeah, mainly in the human resource department only. But some of the psychologists they will be used for recruiting new people. Some of the psychologists they will be used for promotions inside the company. So, like when I was doing my bachelor's at that time, one of the papers in psychology that I did one of the semester was human resource management, and that was I think this last year. That means the second last semester. Yeah, second last semester. And the people in psychology department they got really like good placement in different companies in the HR department. So if that interests you, that is also one field that you can choose. But if you are more interested with MBBS, then again, like no one can deny that MBBS is a bad field. They can say anything against MBBS. Okay, one more people. Yes, Krishna, I saw that you won some medal in badminton.
Yes, and there was some
For that.
inter-school clusters. There was some
Okay.
badminton competition.
Oh, okay. So, for how long have you been playing badminton?
It's the past 6 years.
Oh, past 6 years. I mean, have you been trained also? Did you take some classes?
Actually, I started playing in a club, and then
Okay.
then my
Then?
parents sent me to a training master. Then I got trained a bit.
Oh, really nice, really nice. Whom do you follow? Okay, fine. Wait a second. Lin Dan or Lee Chong? Do you watch? But first of all, do you watch badminton?
Yes, sir, but I do not know their names much.
Actually, you do not know the names. Okay, so there was a rivalry. Like I think you will be not watching that much at that time when the both of these players have retired. I think in the past 3 or 4 years. I think so. I don't remember the name. So we had two. One is Lindan from China, and the other was Lee Chong from Malaysia or Thailand, somewhere there. I don't remember exactly. They had the like it was a competitive rivalry, like you have with Roger Federer and Rafa Nadal. Nadal. Yeah,
Nadal.
between Federer and Nadal. Yes, Matthew, you're saying something?
No, I was just correcting you saying Nadal. So yeah, it's Nadal.
It is Nadal only, no? Not Nadal. Nadal.
Yeah, it's Nadal. Yeah. Spanish.
Nadal. Yeah. It's Nadal. There is one new player in India, right, Krishna? Recently, who won, I think, in Commonwealth. I don't remember.
Yes, sir, I
PV
think so.
Yeah, I don't remember his name.
Yes, sir, PV Sindhu only.
PV Sindhu is the not new, na? PV Sindhu has the one silver also in
No,
Olympics. I
yeah,
think.
but she won gold, right, in Commonwealth.
She won gold. There is also a man, like in men's, we have one badminton player. He's pretty young. I think he's 21 or 22, like that only. He also won gold. I don't remember his name actually. Like the people who get trained in academies for badminton, and then the people who play naturally well, like, but still there is a huge difference. In my school, I had one of my friend. He used, like, he was very good at badminton, and it was only because like the village where he came from that had a legacy of good badminton players. So he kind of absorbed a few things. And my schooling was in Jamia Islami, so people were from all over the country. Like I had people from Bihar to Kerala also. So he used to play really good. But again, there was a guy, and he used to play for Delhi, and he was being trained at some coaching institute. I don't know what coaching institute, but he used to be trained. But the difference between my friend and that guy, it was huge. But again, then my friend is also not very bad. He was very good. Like we had a match, and I think it was like one match was won by my friend, and the two match was lost. Then my friend, he went to IIT Roorkee, and then he used to play for IIT Roorkee. No, IIT Roper, I think. I don't remember exactly. He used to go for badminton. Okay, just one thing you should focus here, that you don't forget to change this to seconds. Okay, please change this to seconds. And as I told you last time, the only two formula that you need is Q is equal to IT, and Q is equal to delta OS into number of moles. Okay, so from here, first of all, you will calculate, please see the circle things. You will calculate the number of moles for mg. Then this delta OS, it requires reaction. So you'll write the reaction. And from reaction, you are going to get the delta OS. You will get the delta OS. Once you get the delta OS and you will get the N, you are going to get the Q. Okay. So once you get the Q, you can plug in the Q here. Time is given, convert it to seconds, and then you can completely calculate I. Okay. So these are conceptually, like, it's very easy. You don't have to figure out many things here. There are only two equations, and you have to play with these two only. Calculate the number of moles, write the reaction, determine the change in the oxidation state of Mg, multiply both of them, and then you will get the Q, as we say, you will get the Q as Faraday. But here, when you're writing, you have to convert it to coulombs. That means 96500 coulombs. Okay. So you have to keep in mind these things. Time should be in seconds. The charge should be in coulombs. Once you're done, send the answers to me, okay? On WhatsApp. What happened, guys? No answer till now. Okay, send me two things, guys. Number of moles and the reaction that is happening. Okay, Krishna is sent right now. Yeah, that seems 16. That seems correct, Krishna. Other, please send me the number of moles of Mg and the reaction that is taking place. Magnesium, what you have done? You have been given, na Matthew. What is the atomic mass of magnesium? Why are you writing 95?
Oh yeah, sorry, sir.
MgCl2 का calculate कर लिया आपने
I
क्या?
took the whole of no, I took the whole of MgCl2. Yeah, that's what I did.
हाँ, वही हमको लग रहा था. Okay, it's for Mg, number of moles of Mg. That's 1.2 gram. Shaheen, छोटे छोटे mistakes इनका ध्यान रखिए. This is 1.2 gram, not 12 gram.
Okay, sir.
Okay, please see here, guys. So what's happening? Here we are having, what do we have here? Number of moles will be equal to the given mass upon molar mass. This will be equal to 1.2 grams divided by 24 grams per mole. Grams and grams will cancel each other. You are going to get 1.2 divided by 24 mole. Just keeping it right now like this only. Keeping it in fractions. Then we look at the reaction, what is happening. The reaction is MgCl2, Mg is 2 plus here. It is going to get converted to Mg and it is going to require how many electron? 2 electron. That means what is the charge required? It requires 2 Faraday. Right? It requires 2 Faraday. And how is the number of moles we have? Into 1.2 divided by 24. So you can write this as 2 into 96500 into 1.2 divided by 24 coulomb. Right? This is the charge we need. And we have Q is equal to I into T. And that is why I will be equal to Q upon time. Okay. Now Q is equal to 2 into 96500 into 1.2 divided by time is what? 1 hour, right? It's 1 hour, 1 hour. So this will be 60 minutes into 60 seconds. This you are going to get in amperes now. If I cancel things, I can cancel this, and I can cancel this, right? And okay, I have 24 also. Into 24 will be there. There's 24 here. And then I can cancel this and this by 12. And further, I can cancel this and this by 10. So what are the remaining part? We have 965, only 965 divided by 6 into 6 into 10. Okay. So we have 36 divided by 96 divided by, okay, so 36 into 2 point now. I think your answer is correct, Krishna. Calculate this value now. You can even simplify this. 5 ones are, then we have 46 nines are, and then we have 15, that is 3. 193. Yeah, 193. I
So
think this
how
is
are you
now
getting
prime now.
1.2?
Sorry?
So 1.2.
So it's 2.6, right?
2.6? Yeah, 2.6.
The answer.
2.6 now. What did I say?
No, so I was just confirming it, but I think you.
No.
Yeah.
I'm just dividing this by 5 right now. And this will be 2. You can calculate this. This will come out to be 2.68. Okay, right next. Conductance. Okay. Now you must have learned about metallic conductance in physics class and also in the class 8, where you first started learning about metals. Metal also has a property of conducting electricity, right? But today you're going to learn about a new conductor, that is electrolytic conductor. Is right? There are 2 types of conductor. The number 1 is metallic conductor. And the other one is electrolytic conductor. Now we are going to write some differences between metallic conductor and electrolytic conductor. The only similarity is that both of these are conductor. That means they can conduct electricity. What are the differences between them? We are going to write it down. So you can draw something like this. Make it big, okay? If you're making a table, it's not going to be of 3-4 lines. right here. Metallic conductor. Electrolytic conductor. Right, the first point, the charge carrier in metallic conductor is electron. What is the charge carrier? Electron. And the charge carriers here are the ions. Zn2 plus, Cu2 plus, SO42 negative. These are the ions which carry electricity. Right, next. When I'm passing current through a metallic conductor, the chemical property of that metallic conductor is not changing. That means if it is copper, it is going to be copper only. So you'll write no chemical change occurs. No chemical change is seen when current is passed. But when we pass electricity from through electrolytes, then electrolytes get deposited, right? So, right, it involves decomposition of electrolytes when current is passed. Now, this does not involve transfer of mass. But when something is getting deposited, that means something from the solution, it is getting deposited on the electrode. That requires a transfer of mass, right? It involves transfer of mass. And this one you have to answer. Conductance dash decreases or increases on increase in temperature. For metallic conductor, what is the case? Tell me, guys, conductance increases or decreases on increase in temperature? Metallic
Increases.
conductance
Decreases.
decreases, right?
Yes.
Decreases, okay. Metallic conductance decreases or increase in temperature. And electrolytic conductance, since we are having ions, if I increase the electricity, if I increase the temperature, those ions are going to move very fastly. And when those ions move very fastly, the current is to be passed on very quickly. That is why the conductance increases on increase in temperature. Okay. And why the metallic conductance decreases on increase in temperature? See, there are two things. We have electrons which want to move, right? We have electrons which want to move, but these electrons are inside atoms, right? If I'm going to have copper, then these copper will be having atoms. And here are the electrons that we have. Okay, here are the electrons. Now, what happens if the temperature is not very high? These are in kind of like the electron pass and like the vibration of electron, they pass very easily. But when I'm going to increase the temperature, not only the electrons are passing, not only the electrons are moving, but these atoms will also vibrate very vigorously. And when these atoms are vibrating very vigorously, it creates a kind of hindrance in the vibration of electron, and the electrons are not passed very quickly. Okay, that is the reason. So the lattice that we have, the complete lattice that we have now, if you remember some of solid state, the complete lattice that we have, it starts shaking like this. And when it starts shaking, the electrons, they cannot transfer energy efficiently. That is why on increasing the temperature, atoms start to move, which leads to a movement and vigorous vibration of lattice, and it hinders the movement of electron. Okay. Now, once you're done with this, let us revise a few things about conductance, conductivity, and these things. Okay. So please write conductance. What is conductance? Is the property of a substance. Property of a substance which gives an idea about the gives an idea about the ease of flow of current and is measured as reciprocal of resistance, as reciprocal of resistance. So conductance is denoted by the letter G, and G is equal to 1 upon R. R is your resistance. The unit for G is going to be ohm inverse or mho, or in chemistry we generally use Siemens. And all of these are same. Okay, 1 ohm is equal 1 ohm inverse is equal to 1 mho, and it is equal to 1 Siemens. It is Siemens is written as S. Right, next conductivity.
So can you scroll a bit up?
Yeah, sure, sure. Click here also. Conductivity.
Done, sir.
Right, next. conductivity. This is a reciprocal of resistivity. Okay, we'll define it, but we'll define accordingly. Okay, right now, what it is? It is the reciprocal of resistivity. That means it's denoted by kappa. Kappa is equal to 1 upon rho. Okay, and what are the relationships? Now write the relationships. What is R? This is equal to rho into L upon A. So what will be rho? Rho will be equal to R into A upon L. Right? A will go there, L will go into the denominator. Now, what is kappa? Kappa is equal to 1 upon rho, and this rho is equal to 1 upon rho is equal to R into A by L. So I can write kappa is equal to 1 upon R into L will go above, denominator of denominator is numerator, that is why L upon A. As we can see that 1 upon R is nothing but conductance into, this is known as cell constant. Okay. Right next. Cell constant. Is equal to L upon A. What is L? In chemistry, L is going to be the separation between the electrodes. What is the distance between two electrodes? Separation between electrodes. And what is A going to be? It is the cross-sectional area of electrodes. Then there is one of this, me.
Yes, sir.
Is everyone done till here? Right, one more point about cell constant. Cell constant is independent of concentration. Now, as we saw, that kappa is equal to conductance into L upon A. Now we are in a perfect place. Once we have got the formula in hand, we can perfectly define what is this constant, right? Because this kappa is going to be a constant. It is a constant. Now, constants are defined by putting all the variables like this, L upon A as unity. Okay. If L is equal to 1 centimeter and A is equal to 1 centimeter square, then what will be the kappa? So A is equal to 1 centimeter square and L is equal to 1 centimeter. And in that case, kappa will be equal to nothing but the conductance G, right? It is conductance. So I can say conductivity is what? The conductivity is the conductance offered by 1 unit volume of conductor, right? Because when you have length is equal to 1 centimeter and area as 1 centimeter square, the volume is obviously going to be 1 centimeter cube. That is again unity. If you don't know this, please see. So if I have this area as 1 centimeter, and this is my length here like
Yeah,
this,
volume
this is
is
going
like
to be a
area
height.
times length, right?
Area times height, yeah. So this is 1 centimeter. And if you multiply both of these things, you're going to get volume. Okay. So those who have left maths in 10th class, it's sometimes difficult to remember this thing, but area times the height or 1 unit length, it is the volume. Okay, so please write the conductance offered by unit volume of conductor is called conductivity. It's called conductivity. Now, very important, please see here, please see. Please stop writing. If I have for 1 centimeter cube volume of solution, conductance is equal to conductivity. Conductivity, that means it is kappa, that is equal to kappa. That means if I have 2 centimeter cube, then it will be twice of conductivity. If I have 3 centimeter cube, it will be thrice of conductivity. If I have 4 centimeter cube, it will be the 4 times of conductivity. And similarly, for V centimeter cube volume of solution, the conductance is equal to kappa times the volume V. So I can write one more formula. Conductance is equal to kappa times the volume. The volume here is in centimeter cube. Okay. What is V? Volume of solution in centimeter cube or ml. Okay. You must know that 1 centimeter cube it is equal to 1 ml. 1 milliliter. Done, guys? Yes, please tell me.
No, sir.
Is everyone done?
Just mention.
This one. Okay.
Done, sir.
Okay. Right next, molar conductance or molar conductivity. Is represented by lambda m, or also sometimes as this is lowercase lambda, this is uppercase lambda. Right? Definition: the conducting power of ions produced by reduced by 1 mole of electrolyte in a given volume of solution is called molar conductance. Is called molar conductance. There is nothing, it is again just the conductance that is provided by 1 mole of electrolyte. Conductance that is provided by 1 mole of electrolyte. Okay, tell me one thing. Don't write this, okay? If I say, let's suppose if solution has concentration of 2 moles per liter, then you have to tell me how much volume is occupied by 1 mole of electrolyte. Tell me, guys, 1 mole of electrolyte will be present in what volume of the solution? 1 mole of electrolyte will be present in what volume of solution? You can expand this. What does it mean? It means 2 moles in 1 liter. Then that means 1 mole will be in how much liter?
Half liter.
Half liter, right? So I can say volume, it is equal to what? Volume is equal to half liter. Ka matlab, if I talk in ml, it is going to be what? 1000. This was the total divided by 2. This is the molarity. Yes or no? That means 1000 divided by whatever the molarity is. That is going to be your what? The volume in centimeter cube, or I can write ml. Correct, guys? Yes or no? Please tell me. Volume of 1 mole. Volume of 1 mole, you can write it as 1000 upon m. If I want to write it in centimeters, we know that conductance is equal to what? Sorry. Conductance G is equal to kappa into volume. What is the volume of 1 mole? Kappa into 1000 divided by the molarity. कंडक्टिविटी का हम लोगों ने ये नहीं लिखा है ना, यूनिट नहीं लिखा है. Okay. We'll write the okay. Wait. This is going to be your lambda m. Okay, this is your G.
So we can use the capital form also.
Sorry.
So the capital form of lambda.
I mean, both are usable. I mean, there is no issue. If you want to write, you can write capital M also. Small m generally एक ion के लिए use होता है, but again, both of these things are molar conductivity only. Small lambda or capital lambda. Okay, write here 3 units of kappa and molar conductivity. So we know that kappa is equal to R into E upon L. right? R is equal to L upon A. We can sorry, kappa. ठीक है. 1 second. This will be 1 upon R, na? Conductivity में, yeah, 1 upon R. That will be for resistivity. Just a second, please. Conductivity is equal to 1 upon R, and the cell constant is L upon A. L upon A, yeah, L upon A. So 1 upon resistance, it will be equal to what? The unit of this is G into L upon A. So G ka unit Siemens, L ka unit centimeter, A ka unit centimeter square. This will give you centimeter, sorry, Siemens per centimeter. Yeah, correct. Then we have lambda M, that is equal to kappa upon the molarity, but we write into 1000. Now this 1000 is nothing, it is having a unit of centimeter cube and liter inverse. Why? We are multiplying 1 in order to get centimeters in centimeters. So kappa is Siemens per centimeter upon molarity is moles per liter into centimeter cube into liter inverse. Here we have liter inverse in denominator, there we have liter inverse in numerator. Liter inverse get cancelled. Centimeter minus 1, and here it will get centimeter square, and you will get the unit as Siemens centimeter square per mole. Siemens centimeter square per mole. Read this question. The electrical resistance of a column of 0.05 molar concentration in a solution of diameter 1 centimeter. That means it is a circular column, and length 50 centimeter is fine. This much is the resistance. Okay, so we have been given the resistance that is equal to 5.55 into 10 to the power 3 ohm, and we have been given the L that is equal to how much? 50 centimeter. Okay, to calculate the resistivity, okay, from their conductivity, and from conductivity molar conductivity. Okay, so here we need the area, right? So area is not given. We need to calculate area. How are we going to calculate area? We are going to calculate area as pi into r square. So for pi, I will keep 22/7. R I can keep 1/2 because diameter is 1 centimeter. Radius will be half centimeter square. So this will be equal to 22/7 into 1/4. This is going to give me 2s and 11s, so 11 upon 14 centimeter square. Okay, so we have got the area also, we have got the length also. Now we can calculate the resistivity. So resistance is equal to rho into, resistance is equal to what? Rho into L by A. Resistivity R is rho is equal, sorry, R is equal to rho into L by A. Rho is equal to R into A by L. So what is the R? 5.55. 5.55 into 10 to the power 3 ohm. Area is 11 upon 14 into, this is centimeter square, into length is 50 centimeter. Okay, so you can get resistivity as ohm per centimeter, ohm centimeter. I'll say. You'll get the resistivity as ohm centimeter, and it's the inverse हो जाएगा आपका conductivity. Calculate this value and then calculate the conductivity also. Send the answer in Zoom chat only. I don't think that's going to be this huge though. Matthew, I think you're messing up with somewhere in the decimal. Krishna, that's more right, I think. Matthew, you're messing up with the decimal point.
I will calculate it again, sir.
Yes, I think Hamza, yeah, that's correct, Hamza. Okay, Matthew, it will come out to be 87.2.
Yeah,
centimeter.
I messed up the decimals. Yeah.
Okay, then we have to calculate the kappa. This is nothing but 1 upon rho. Okay, this will be 1 upon 87.2 ohm inverse, centimeter inverse, or Siemens per centimeter inverse. That you can calculate. Okay, that's not a big deal. Then we have to calculate the molar conductivity. So lambda m, it is equal to kappa into 1000 divided by the molarity. So kappa we have got it as 1 upon 87.2 into the molarity is 0.05 into 1000. So this will come out to be 1000 into, I can write this as 10 to the power minus 2. This will go about 10 to the power plus 2 divided by 87.2 into 5. Calculate this value. What's the answer, guys? नहीं निकला अभी तक? 157. No, I don't think so. Yeah, that's more right, Matthew and Hamza. It will be somewhere around 230. $229.3 and 4. Yeah, that's fine. Siemens centimeter square mole inverse. Okay. Right, next topic. Factors affecting molar conductance. Right, number 1. Nature of electrolyte. That means whether we are using a strong electrolyte or a weak electrolyte. Please write. Lambda m of strong electrolyte is higher than weak electrolyte. You will write a strong electrolyte and weak electrolyte completely, okay? Is higher than weak electrolyte because strong electrolytes dissociates completely. And when it dissociates completely, if I'm going to take 1 mole of electrolyte, it is going to give me 1 mole of the complete ions will be complete electrolytes will be dissociated into ions. Okay, so we'll have more ions, and if we have more ions, then we have been getting more electricity. Lambda m of strong electrolyte is higher than weak electrolyte because strong electrolyte dissociates completely. Right, second one. Size of ion. Size of ion. Smaller the size of ion, greater will be ionic mobility. That means ion will move faster. Ionic mobility. And higher molar conductivity. Right, the third point, temperature. Right, the interionic interaction decreases. That means ions do not interact with each other much when we increase the temperature. Decreases as the temperature increases. Due to which ionic mobility increases and lambda m also increases. The fourth point, which is important, the concentration. Okay, for concentration, right? When the solution is diluted, the molar conductivity of electrolyte increases. Electrolyte increases because with dilution, dissociation of electrolyte increases. Also, if you look at the formula of lambda m is equal to what? Kappa into 1000 divided by the molarity, right? Divided by the concentration. So we can say that lambda m is inversely proportional to concentration. Since it is inversely proportional to concentration, it will be directly proportional to dilution. This is an important concluding point about the concentration. Okay, it's also a bit of counterintuitive. If the concentration is increasing, we think that the molar conductance should also increase, but that is not the case. You can look at the formula. You can see why it is not the case. Okay, now if I will dilute the solution into infinity, that means we are going to add water, then concentration is going to decrease a lot. There will be a point that after which, even if we decrease the concentration, even if we dilute it more, the conductance, the molar conductivity is not increasing. That particular concentration is known as infinite. That is known as infinite dilution. Write a heading: infinite dilution. Infinite dilution. Please write. This means the solution is so dilute. Solution is so dilute that lambda m molar conductivity attains a maximum. Maximum means that is the limit. उसके ऊपर जा नहीं सकता. Attains a maximum or limiting value. And it does not increase on further dilution. Does not increase on further dilution. Now write a note. This note is about conductivity. See, the molar conductance and conductivity they show like different type of effect when we dilute it. Okay, when we dilute the solution. Please write. When solution is diluted, number of ions per unit volume decreases. Hence, conductivity. What is conductivity? Kappa. Hence, conductivity of solution decreases. Okay, that means kappa is directly proportional to concentration and kappa is inversely proportional to dilution. Done everyone? Yes or no, please tell me.
Yes, sir.
Is everyone done?
Done, sir.
Yes, sir.
Done. Sure. That's it for today. There is a small portion of effect of dilution uh, on the molar conductivity of strong and weak electrolytes that we have to do, and Paul-Roche law of independent migration. These are small topics that will be completed, and then we will do some more numericals, okay, in the next class. And that will be your last class. Okay, one question that I wanted to ask is, I think in all of your schools, Shaheen, in your school, at least I think chemical kinetics has been started, right, Shaheen?
No, sir.
Nahin?
This chapter just ended, but new chapter haven't started yet.
Acha, acha,
We're
acha.
still discussing numericals about it.
Okay, okay. Matthew, what about you?
No, sir. We did DNF block instead.
DNF block. Matthew.
Yes, sir.
Okay. Matthew, you previously you were in which batch? B or E?
So I had I had Tuesdays and Wednesdays. For
Tuesdays and Thursdays, no?
Thursdays. Yeah, sorry, Thursdays.
Okay, okay, fine, fine, fine. Okay, okay, fine. So you're in Abu Dhabi. I mean, you're different school. Okay, fine. So, what about Krishna?
So we're still in the same lesson.
Electrochemistry only.
Yes, sir.
Okay. Hamza and Eba, what about you guys?
So we are about to finish biomolecules.
आवाज ही नहीं आ रही है आपकी.
So we will be finishing biomolecules by this week.
You have started biomolecules. That's what I can hear. Okay. Eba, what about you? Which chapter? Yes, electrochemistry. Okay, it's still going on. Okay, fine. Okay, so what I was thinking is that like biomolecules, for some people it is there, for some people it is not there. I was thinking maybe on Friday, some Friday, I will take a class on biomolecules. Okay, and do you guys have holiday the next week somewhere? It's like it's the complete week is Puja week, right?
Yes, sir.
And you don't have any holidays. It seems like your exams are going on. There's no holiday.
No, sir. No holiday, sir.
And I wonder,